got Hayden with us, who's going to get on the chat. She's a graduate student, so she'll be able to answer anything that you need. So the first thing I'd like to say is that, you get a lot more out of these sessions if, you try the questions in advance, and also if you participate. So just participate however you can. That might be by talking to Hayden, or it might be by talking to, one of your peers. You can chat in front of everybody. So on the chat function, there's a drop-down box which says who you would like to talk to. You can send a message directly to myself, directly to Sarah Lees, because he's here, or directly to Hayden, or to each other. If you've got a question which is like, oh, what did Miss Sexton just say? Like, if you know somebody else on the course, like, and you feel a bit embarrassed to say it in front of everybody else, just ask them instead. Now, what I'm going to do is I've got the answers to all of the questions, and I know how to do it. So I don't think it's greatly beneficial for you to just see me go through the answers to the questions, because we all know that I know how to do it. That's not what's relevant, is it? It's about you guys learning how to do it. So what I'm going to start off with, I'm just going to start off with the easy questions, which was the first two, about what type of data and how we select things and stuff like that. We're just going to have a little chat about that. And then I was going to pick out maybe two of the other questions and go through them really, really slowly, just because I think fitting all of them into 45 minutes is really tricky. And I'll point out where I found things difficult, because when I first met this topic of finding, means and variances of samples, and what those things would look like as an undergraduate, I was really confused. I was just like, what, but, and had so many questions about what these parameters actually were, that I thought I would just like mention a little bit about that as we go along. Okay, so I am going to switch to sharing my screen so we can see what the question was. Okay, so we can see the questions here. So the first question is about a by-election, which is due to be held next week. Now, if you're British, you'll know what a by-election is. If you're not, maybe you don't. So this is an election that happens just outside the normal cycle. Maybe the MP dies or something like that. And in this by-election, we've got candidates from all of the major parties. And we would like to select some people to question about how they're going to vote. And Sarah Lees has given us some suggestions as to how we might select that sample. So the first one is taking a poll of people who are voting age attending a local football match. And yeah, some extra people joining, so I'm going to try and keep on top of that as well. I think this one would be biased. What do you think, Hayden?
I think it would be fine.
Yeah. Okay. So, any thoughts about why?
Maybe.
Yeah. Well, yeah. I think that only certain types of people are going to be going to football, aren't they? So maybe like you might get more people who like read the Daily Mail who go to the football. So you might get more conservative voters who go to football. I don't know. It depends where the town is. Maybe if the town is in the north, so you'd get more Liberal voters. I don't know. So maybe that one's a bit skewed because only certain people like football. I certainly don't like football. I wouldn't be there. So how about leave it? And the second one, again, I think maybe this one's biased because we're going to have some very posh people in that sample. And they might be more likely to, well, maybe a few years ago I would have said they'd be more likely to be Democrat, but again, maybe more likely to be Conservatives again. Okay, and the third one is obtaining a copy of the voter registration list and randomly choosing 500 names and questions much about their voter intentions. So if we can definitely get in touch with all of those 500 people, I think that one might be all right. Because it's nice and random, you know, we've not got any extra factors other than the fact that they're voters going in there. And then the fourth one, we've got a telephone poll on a television station. So I'd never get selected under this one because I don't watch TV, or at least not on a conventional television anymore. So I'm pretty sure it would miss a lot of young people. So maybe that one's biased as well. And 5, I think, was a bit of a trick question. I think Sarah Lise is a bit mean with number 5, because it looks like it's going to be unbiased because we've got 200 names randomly from the telephone directory. And then I thought, oh, no, it's not, because not everybody has a landline anymore. I mean, I don't have a landline. Well, I probably do, but I've not got any telephone plugged into it. I've just got the internet plugged into it. So if you tried to call my landline, you wouldn't get anywhere. So again, we're going to miss a lot of people if we do that type of thing. So question 2 is the same kind of thing. So we need to think about what the properties of everybody is like. So and then how we're going to pick out a group of people and make sure that those are actually like the group of everybody that we're looking at. So these kind of properties that we were talking about in question 1 and 2, they're actually like running through questions 3, 4, 5, 6 as well. So what they're talking about in all of the rest of them is about having a population. So this is something that we often can't measure. Now, confusingly, in question 3 and question 4, you can measure it because it's only got like 5 elements in. So, I mean, that sort of was the type of thing as an undergraduate where, you know, I looked at it initially and I was like, yeah, but we can measure this. Like, why are we even doing this? It's very confusing as to why I'm taking a sample of size 2. If there's only 5 people overall, I can just go ask all 5 of them. But, you know, the problem with this, as far as I'm aware, is that it's just very illustrative because we can actually pick out all of the possible samples. Whereas, you know, usually we can't pick out all of the samples. Let's have a look at question 3. I'm going to switch over to my visualizer. Yep, I'm on there. Background. Dear. There we go. So that's something to bear in mind, is that I can't see my page if I've got my background, the black background on. So let's go. Right. So for question 3, what we had going on we've got a sample with replacement. So in this case, we can actually measure, we can observe all of the data. So we've got our total population of data, which Sarah Lise is denoted by a capital sigma. And we know that this can take one of 5 values. We've got 2, 3, 6, 8, and 11. So the first couple of parts of the question are not too bad. So the first thing he's asked us is, what's the population mean and what's the population variance? So because we can observe all of our data points, we can calculate these really easily. So the population mean is just the mean in the sense that, you know, you probably understand it up until this point. So what we need to do is we need to take a sum over the possible values of theta. So what we've got is and we need to divide by how many there are altogether. My little xi is values of the actual realization. So in there, I'm going to put 2, 3, 5, 8, and 11. So 1 over 5, and then sum 2 plus 3 plus 6 plus 8 plus 11. And overall, this one is 30 divided. Oh, I've missed a point. No, I haven't missed a point. I've got 30 divided by 5, which is 6. Okay. And for the second one, I want to find the variance, and we know our formula for the variance. So this thing is called mu. Now, often you can't observe mu, your population mean, but in this case, we've been able to calculate it. The second one, we would like to find the population variance, which is sigma squared, and we've been given a formula for this. So we've been given 2 formulas for it, but in this case, we can use the one that is like this. So we need to do this. So again, I can just stick in each of my values of the little xi that I've been given in the population here. So I'm going to have 1 over 5. And I'm going to move my mouse out the way so that I can get my page in exactly the right place so that you can see exactly what's going on, because I've lost everybody. John has asked in the questions, how do we use the biased and the unbiased formula? So that's jumping ahead a little bit, because at the moment we're talking about the population. So we're talking about, the measurable, or rather the overall property of the variance of everything altogether. When we come to the biased and the unbiased formula for the variance, what we're talking about is we're talking about the variance of some subsets of the population that we've looked at overall. So we're not actually, we're looking at estimates for the population variance, not the actual population variance. Now, in this case, we were able to calculate the actual population variance because we know what's going on for each and every member of our population. But when we come to having to estimate it, then we need, then we've got the biased and the unbiased formula. So we'll come to that in a minute. Kieran's posted a number, which is 13.5, and I'm not too sure where that has come from. Okay. When I calculated the value of this, I got something slightly different. So I needed to take each of the individual values of xi, each of the ones in here. I subtract off the mu that I've just calculated in the previous section, and I square them. So the terms in my sequence are going to be 2 minus 6 squared plus 3 minus 6 squared plus 6 minus 6 squared plus 8 minus 6 squared plus 11 minus 6 squared. And overall, what I'm going to end up with is 54 divided by 5, which is 10.8. Okay. So in the third question, what we were asked for is we were asked for the mean and the variance of all of the possible subsets. So the first thing we need to think about is we've been asked to take a sample of size 2. Okay. Now, we don't know which one of those samples we're actually going to pick. So we're going to call it a random variable. So I'm going to call it X. So x is a random variable. It's going to have two separate elements. It's going to have the first number that I choose and then the second number that I choose. So it's going to look like this. x1, x2. And I've been told that I am allowed to replace the elements after I've picked one out. So both x1 and x2 can take all of the possible values in sigma. So the first thing I'm going to do is I'm going to think about how many possible samples I can take. So you might be saying, oh, why the hell am I taking samples? There's only 5 elements in this population. Now, one way of thinking about it is if I wanted to say, estimate how the average height of somebody in this tutorial, I could go around and I could measure absolutely all of you, and it would involve taking lots of international flights, and I'd have to, you know, spend a lot of time going around to measure all of you to get a good statistic. Or I could just pick a couple of people. Now, I could pick the ones that are closest to me, the ones that are in the UK, and go around and measure them and guess from them. And that's effectively the type of thing that we're doing here. Now, I might get a biased result if I only pick the people who are close to me, but let's not worry about that for now. And the idea is that we pick a smaller group and then we look at the properties of that group and we see, and then we want some way of deciding whether the, you know, the properties of the subgroup are close to the properties of the population overall. So the point of this question is just to verify that Sarah-Lise's formula that he's given you in the notes works nicely. So the possible combinations we have, we could pick 2 and 3. We could pick 2 and 2. And there's lots of combinations that we could pick. So we could also do 2 and 6, 2 and 8, etc. So I'm just going to write out all of the possible combinations that we could have, right? Well, I'm going to do the first 2 lines, and what I'd like you to do, if you don't mind, is find as many of these combinations as you can. Now, I think there's going to be I think there's going to be 25 of them, because I think we're going to have, in the first number that we pick, we're going to have 5 possible choices, and in the second one, we're also going to have 5 possible choices. 6, 2, 8, 2, 11, 2. Okay. So the first thing I'd like to get you to do, if you don't mind, is can you fill out all of the extra remaining terms there for me? And I'm going to give you, I don't know, maybe 2 minutes to do it, because you know, you need some writing time to sort of catch up a little bit. I'm hoping you can see very, very clearly what's going on the visualizer. If you can't see clearly, of course, please just tell me in the chat that the visualizer is rubbish, so I can adjust it. I do realise that my handwriting is really, really small and scratchy and nowhere near as good as Sarah-Lise's. But, you know, you are going to get the solutions, you know, at the end of the week, so you can look over at the solutions. So, yeah, I'll just give you a second to just finish filling out this grid of all of the possible permutations from our sample. Right, so I hope we're all ready. So the next thing what we want to do is we want to try and find the mean in each of these cases. So The average, so the mean realisation, if we pick this particular sample, is 2, because we've got 2 and 2, so it's definitely the average is 2. In this one, we've got a 2 and a 3, so the mean is going to be 2 plus 3 divided by 2. We've got 2.5. In this one, 2 plus 6, 8, divided by 2, we've got 4. This one, 5. This one, 13 divided by 2, 6.5. Okay. So if you could continue on like that, that would be great. I'm going to do the next row as well, just so that we know what we're doing. But if you can just fill out, we're going to have 3 and 5 there as well. If you can just fill out the values there, that would be awesome. Okay. So nobody told me that I'd run off the bottom of the page. Okay. So because we don't know which sample we're going to have selected, you know, if we're just picking two elements from this population, we don't know which sample we're going to have selected. The mean is actually going to be a random variable. And the mean, we're going to denote x bar, is going to be one of the values in this second table that we've drawn. So when I say, so when Sarah Lee says he wants to find the mean of the sample mean, he's not actually, it's not actually a tautology. What he's trying to say is he wants to find the mean of all of the values in this table. And we've got a theory about how this mean actually relates to the population mean that we found at the beginning. So once you've filled out the 25 values, what we're going to do is we're going to try and summarize them. So we've got ones that occur more than once. So we've got 2.5 is actually cropping up twice. It's once here and once here. But 2 is only there once. It's only here. So the next thing I'm going to do is I'm just going to make my life really, really easy by drawing a table. So I've got M. M's going to be the possible, the unique values in my in the table here, and I've got the probability that I pick a sample that has this mean. Okay, so I'm actually going to put all of these out. So I've got 2. So the only place you should have 2 in the table here is up here when we selected both 2 and 2. So we're going to have one entry where the mean is 2. We've got 2 there with 2.5. And when you filled out the other 15 values, you shouldn't have found another 2.5. So that one's going to occur with frequency 2.5. 2 out of 25, so. And then the other possible values are 3, 4, 4.5, 5, 5.5, 6, 6.5, 7, 8, 8.5. Ooh. Run out of space. 9.5 and 11. Okay, now the ones on the diagonal, so 2, 3, 6, 8 and 11, they only go in the table once, so each of those are going to have frequency 1/25. Okay, now everything else crops up twice except for 7. So everything else is should go in your table twice. Except 7. Okay. So we're closer to finding what we needed to with part C now. So what we were actually asked to calculate was the mean of these X bars and the variance. Okay. So to calculate the mean, we're just going to use the same formula that we have for the mean in general that that you've seen in probability 1. So what we're going to do is we're going to sum over all of the possible values, and we're going to have m times the probability that X bar equals m. And we have all of these values from the table. So if we look at the table here, we know that we just have to run through the values of m and the values of px there. So I'm going to have a factor of 1/25 for all of them because there's 25 elements. And then I'm going to need 2 plus 2.5 times 2 plus 3 plus 4 times 2, etc. And the final number I'm going to get is a 6. And that's sort of what I would hope for. I'd hope for that because Sarah Lees has shown you in the asynchronous material that the expected value of X bar is equal to mu. So this is as we would expect. Okay. And the variance we're going to do similarly. Now, previously, I calculated the difference between the realizations and the means and squared them. But I'm going to use the other formula for the variance just to sort of, show you that you can do it either way. So I'm going to use the one that says I'm going to sum over m squared px equals m. Minus the square of the means. So in this case, it's the sum of m x equals m, and then square that one. Now, in this case, because we've got lots more possible options for what m is, this one is a bit more easy for me to do because I've already got the calculation for the second term here. So I know this one is, so this one here is fine. I know this one is 6 squared. And I just need to calculate this one, which is going to be 1 over 25. And then I've got 2. Need to run through squaring each of these and multiplying them by the number of times that they were in my table of realizations. So I'm going to have 2 squared plus 2.5 squared times 2 plus 3 squared. 4. Okay. And if I crunch all of these, I'm going to get 41.4. Now, in your solutions, you're going to see, the R code to help you do that. And now how I would do that is I'd either do that, with R really, really quickly, because it can do calculations on each element in a vector for you, or I'd probably do it with a spreadsheet. So somebody's asked me a really long question. In fact, Hayden's given us a really good explanation. Okay, so you can read through that about biased and unbiased estimates for the variance. In this case, I've used the 1 over 25, and you are probably going to see in the lecture notes exactly why you shouldn't probably use the 1 over 25, why you should be using 1 over 24 instead. So Sarah Louise is probably going to show you that, I think, in the next lecture, why it's important to use an unbiased estimate for sigma. So we're sort of, the point of trying to find the mean of those sample means is that we want to try and use that as an estimate of the population value, that we don't necessarily know what it is, and the same with the variance here. Okay, so we've got about 10 minutes more, and I think what I would like you to do in those 10 minutes is to, if you haven't done it already in advance in the class, is to look at question 4 and question 5 using the same method that I've just run through there. So what we want to be doing is we want to be looking at what are the possible subsamples in each case. So question 4, we've been asked, to not replace the values. So go back to the table that we've written out for question 3 of all of the possible subsamples here. And if we're not going to be replacing, we need to take some of those off because they're no longer possible. So try and decide which ones you need to take off. And then if there's anything else you can do to simplify, what you're doing. I think I'll give you quite an obvious tip, which is this one's not going to be possible anymore if we're not allowed to replace the values, because once we've selected 2 for the first random variable, we're not going to be allowed to select it again. Yeah. So give number 4 a go with that in mind. And secondly, try number 5 as well. Now, number 5, I think where we want to start with part B is we want to start with what are all of the possible samples of size 3 that we can take. Now, again, we've been given 5 values, and my hint for that one is going to be that there's 10 possible samples of 3 that we can take. So for the final 10 minutes, try for yourself. Question 4. So the key thing I would like you to think about is what are the possible subsamples? Which elements can we keep? from question 3. And also, or alternatively, question 5. And the key thing I'd like you to think about is what are the possible samples? So with n is 3, so size 3, and hint, there are 10. Okay. So I'm still going to be here for the final 10 minutes. I'm told that we need to wind up by 1:45, just in case you've got something else that you need to be at 10. Hayden's still going to be here. Sarah Lee's is still going to be here, if he's still here. So I'd suggest you work quietly yourself, and so John has managed to figure out what my hint was about, which is, yeah, we don't need the repeat samples. So you can keep in 2 and 3 and 3 and 2 if you want, and divide by 20, or you can just remove all of the duplicates and reduce the number of samples that you can consider. So yeah, John is right that we don't need to consider 2 and 3 and 3 and 2 separately. So he's got exactly what I was asking. Yeah. So John's asking why. So I will just run through why. So the main reason why we don't need to do it is just because we're lazy. Technically, you do need to consider all of the samples order regardless. But what we find is that we've got some, when we get to writing out our table for part 3, so when we write a table like this for part 3, that things simplify slightly. So we can still go through exactly like we did before with 3, 2 and 2, 3 separate at this stage. We can keep that exactly as it is, but just take off the ones going down the lead diagonal. Again, all of our means are the same, except that we don't need to consider the ones down the diagonal because we can't select those. But then what we find is that everything this side of that lead diagonal, so everything on the downside, is exactly the same as everything on the upside. So when I write my table out for question 3, so this, I change this line for question 3. What I'm going to find is that I'm going to be able to simplify. So what I will have is I'll have m, the possible values of m. So 2 isn't going to be there, but 2.5 is going to be there. The same with 4, 4.5, etc. for my possible values of m. And then p x bar equals m. For question 4, I'm going to have 2 over 20 here. Yeah, so the reason why I've got 2 over 20 is because I've taken off 5 elements, so that leaves 20 altogether in this table. And 2 of them are going to say 2.5. I've got that one and that one, they're 2.5. And for the same for 4, so I've got 4 here, and I'm going to have a 4 here as well. Those are the only 2 4s. So I'm going to have 2 over 20 here. And this is going to be the case for each of the elements, other than 7, of course, which cropped up twice. So when I get to 7, I'm going to have 4 over 20. Yeah. Now, I've just realised that when I take the mean, some of those 2's are going to cancel. So when I calculate the sum of m times px equals x bar equals m, this one, I'm going to have 2.5 times 2 over 20 plus 4 times 2 over 20, etc. And I don't need those 2's. I can get rid of the 2's. So I end up just with 2.5 divided by 10 plus 4 divided by 10, etc. Yeah, well, except for 7, which is different, but so it's 7 times 2 divided by 10. Okay. So what I've managed to do is, because this table is symmetric here, this one here is symmetric, what I can do is I can just consider all of the values on one side. I don't need to consider that they pop up twice. And that's where the 2's start cancelling. So I don't have to deal with separately picking 2 and then 3 and then 3 and then 2, because the bottom half of this table is the same as the top half of this table. Is that clear, John? Great. Super duper. So if in doubt, if you're thinking, oh, can I simplify this? Does it matter what order these samples are picked in? Don't panic. Just assume that it does matter. And then somewhere further along the calculation, things will cancel out if the order doesn't matter. So don't worry too much about, oh, how can I make this simple as quickly as possible? Just start from the basic method, and then hopefully something will drop out as we go along. So Mariana has asked, are the answers 6 and 4.04? And I can say reliably, yes, those are the answers. So let me just quadruple check just to be on the safe side. Yeah, Mariana's answers are completely right. So I've still got for the mean 6, and for the variance of x bar, I'm going to get 4.04. So I was hoping to get onto question 6 as well, but I seem to have gone a bit slow. I'm going to try and go a bit faster and get onto question 6 in the Thursday afternoon sessions. So, you know, I'm aware that you all know about all of the tutorials. So if you want to drop along to another one and see the answers to number 6 as well, just so you can get a better understanding, please feel free to come along as well, you know, to one of my other sessions, and I'll try and go a bit quicker and fit that in. So aside from that, we have run out of time because we're meant to be making these sessions 45 minutes. So I'm going to hang around until 10. I don't know whether Sarah Lee's has another session running from 10, so whether he's got more people coming in. But feel free to leave if you're ready, or you can hang around if you've got any extra questions you need to ask. Otherwise, I'll see you all in a fortnight. So enjoy R next week, and I'll see you again when we're back to doing bookwork in a fortnight. Yeah.
Thank you.
You're welcome.
Hi, teachers.
Hello.
Could you please show you how to get 41, the variance?
How to get the variance of the 41. Okay. Right. So what I need to do is what we're being asked for is the variance of x bar, and the formula is we sum over m, m squared px equals m, minus the sum over m px bar equals m, this one, and then all of this all squared. Okay, so what I'm going to need to do is calculate this first term, because the second one I've already calculated. I know what this one is. I've calculated it here is equal to 6. So what I'm going to do is I'm going to do 2.5 squared.
Okay. I know.
Etc. Yeah. 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 So I should be running through those and then use my standard formula. Anybody else like to ask anything? Oh, see, there you can see my kitchen now.
Thank you, Johnny. Thank you.
All right.
I got a class at 10, I think, so I need to.
Yeah, okay, yeah. So you've got another group at 10. Well, lovely to meet you, Sarah Lise.
Yeah.
And I'll see you again at 4 o'clock on Thursday. I'm playing with a poll everywhere page for myself. So I might have like some extra interactivity by Thursday.
Okay.
All right. I'll see you then. Bye-bye.
Bye.
Bye.
Bye. Last night, what I did. Hello guys, how are you? You guys okay? Mm. Good morning to everybody. Good morning, guys. Uh, all right, so this is tutorial sheet 2. There are seven questions in this tutorial sheet. I'll try to go through as many of them as possible. Okay, so let me change the camera just a minute. All right, this is the, I don't know if you can see it, but this is the tutorial sheet number 2. There are, as you can see, there are 7 questions in this tutorial sheet, and I will try to go through all of them if I can. Right. Okay. All right. Let me start with question. I mean, you should be able to see the tutorial sheet from the course website, right? I mean, I send you guys a link for the tutorial sheet. I'm sure you can see the. I mean, this is very blurred, so you may not be able to see this clearly. But if you go to the course website, you should be able to see a clear version of the tutorial sheet, right? So let me start with question 1, right? Question one says the following. It's saying whether each of the, like, okay, we are looking for a representative sample of the waters, right? And let's consider each of the parts. The first part is whether to poll all people of voting age attending a local football club. I mean, that's not going to be a representative sample because not all voters may like football, right? Okay, so all right, so let me write that down. So the part 1 is not representative, not a representative sample. Right? Because not every voter likes football. Right? Okay, guys. So that's the answer to part 1, right? Part 2. If you have any questions, you use the chat box. All right. Part 2 is whether to poll all people of voting age who are living in an expensive restaurant on a particular evening. That's not likely to be representative because not every voter can afford an expensive restaurant, right? So this is again not a representative sample. Not a representative sample because not every voter can afford an expensive restaurant. All right, any questions, use the chat box, guys. Okay, feel free to or talk to me using your microphone also. Part 3 is asking whether obtain a copy of the voter registration list and randomly choose 500 names and questions each of them about their voting intentions, right? That is a representative sample. Representative sample. Okay, that is a representative sample because you're choosing people randomly from a voter registration list. So that's likely to be a representation of the voters in the country, right? Part 4, use the results of a telephone poll in which a television station asked its viewers to call and state their voting preference. Right. This is not likely to be a representative sample because not everybody has a phone, or not everybody watches television. Like, I don't like to watch television, right? So it's not a representative sample. All right, so it's not a representative sample because not every voter may have a telephone, or likes to watch a television, right? Okay, so part 4 is not a representative sample. So part 5, the final part, is to choose 200 names randomly from a telephone directory and call those people. And that is, again, it's not a representative sample because not everybody is listed in the telephone directory, because some people prefer not to be listed in a telephone directory. Okay. All right, because not everybody may be listed in the telephone directory. All right, so this completes question 1 of the tutorial sheet. Any questions on this, guys, before I go to the next one? Hello, guys, talk to me. Hi. Do you have anything you like to ask about question 1 before I go to the? All right, thank you, guys. Thank you very much. All right, question number 2. Question number 2 is this one here, right? So here you have, excuse me. Once again, the question is the same, whether each of these constitute a representative sample or not, right? So this is question 2. Let's look at part 1. In part 1, to determine what the average person spends on a vacation, a market researcher interviews passengers aboard a luxury cruise liner. And this is clearly not a representative sample. It's not a representative sample because only the rich can afford a luxury cruise line, right? All right, guys, so part 2 is asking you to determine the average income of graduates 10 years after graduation. A university sends questionnaires in 2015 to all members of the class of 2005, and bases its estimates on the question as returned. And this is clearly, once again, is not a representative sample. Do you think why it is not a representative sample? It's not a representative sample because graduates are not likely to report their true income. Okay, you see, if a graduate earns say 1 million pounds per annum, then they may think it's too posh to report. On the other hand, if they earn like say 10,000 pounds a year, then they may feel embarrassed to report such a low figure. So the estimates that you get are not likely to be representative. They're not likely to be the true incomes of the graduate. All right. Now, finally, part three is asking to determine the public sentiment about certain import restrictions from a country. An interviewer asks voters, do you feel that this unfair practice should be stopped? Right. And once again, this is because of the wording of the question. This is not a representative sample because of the wording. Of the question. Because of the wording of the question. You see, the question is worded as follows. Do you feel that this unfair practice should be stopped? Because of the wording of the question, even if the people feel it is fair, they may say it is unfair, right? Because the question is worded like this. So the answers are not likely to be representative. The answer to the question are not likely to be representative. All right, so this completes question 2. Anything you like to ask about question 2 before I go to the next one, guys? Or is it, just feel free, man. Don't be shy to answer. Don't be shy to ask any questions, okay? All right. Next is question 3. Question 3 is, I know this is kind of blurred, but if you look at the course website, you will be able to see a clearer version of this question. Right. So in question 3, the first part, all right, you're given a population that consists of these numbers. So the population is has the numbers 2, 3, 6, 8, and 11. All right, these are the numbers it has. All right, and the first part of the question is to calculate the population mean. All right, and we are picking one of these numbers. So we are picking one of these numbers. So the possible outcomes and the corresponding probabilities are as follows. Because it has only 5 numbers, the possible outcomes can be 2, 3, 6, 8, or 11. All right, and the corresponding probabilities are these. Okay. Now to answer the question, which is to find the population mean. to find the population mean, you're looking for the expected value of the number that you chose, right? Which is basically the outcome multiplied by the probability, and then you sum. All right, if you work this out, this will be equal to 6. So this answers part one of question 3. This is clear, guys, or no? All right, now to do the part two of question 3 is to find the variance or the population variance. All right, to find the population variance, sigma squared, which is the variance of x1, yeah, and this is, as you know, I'm sure all of you know this formula, right? This is the expectation of this minus the square of this expectation. I'm sure you guys know this formula, right? And this one we already know is equal to 6. So we just need to compute this, which will be 2 squared times 1/5, and so on up to 11 squared times 1/5, minus 6 squared, which is 36. All right, now if you compute this, this will be equal to 10.8, right? Okay, guys, now any questions you guys have, please feel free to choose the chat room or talk to me using your microphone, guys, all right? Okay, now part three of question 3 is to consider all possible samples with replacement and compute the sampling distribution of x bar, right? Okay, let's see how we can do this. So the first thing you need to do, to do part 3 is to list the possible outcomes. So this is question 3, part 3, right? So the first thing you must do is to list the outcomes for x1, x2, right? And the possible values for x bar. X bar is the average. X bar is the average of x1 and x2, right? And because we are sampling with replacement, there are 25 possible outcomes, which is 2 is a possible outcome. 2 3 is a possible outcome. 2 6. Right, these are all possible outcomes, right? Then you can also have 3 2, 3 3, 3 6, 3 8, 3 11, and you can also have 6 2, 6 3, 6 6, 6 8, and 6 11, and you can also have 8 8 2, 8 3, 8 6, 8 8, 8 11, right? And finally, you can have 11 2, 11 3, 11 6, 11 8, and 11 11. So in total there are 25 possible outcomes. Now what I'm going to do in this column is to write down the average of these two numbers, right? So the average of 2 and 2 is 2. The average of 2 and 3 is 2.5. Right, then 4, 5. So this is 5, guys, okay? 6.5, 2.5, 3, 4.5, 5.5, 7, 4, 4.5, 6, 7, 8.5, 5, 5.5, 7, 8, 9.5, 6.5, 7, 8.5, 9.5, and 11. You see what I've done? I have created a table with the first column giving the possible outcomes, the second column giving the values for X bar, right? Okay, now the next thing I'm going to do is the following. The next thing I'm going to do is to create another table. And this table is going to have 2 more columns. The first column will give you the distinct values for X bar. The second column will give you the probabilities. All right, so now if you look at this table here, the distinct values for X bar are as follows: 2, 2.5, 3, 4, 4.5, 5, 5.5, 6, 6.5, 7, 8, 8.5, 9.5, and 11. So these are the distinct possible values for X bar. The corresponding probabilities, the 2 occurs only one time. See, out of these table, 2 has only one outcome corresponding to it. Now 2.5 has 2 outcomes corresponding to it, which is this one, and this one. There are 2 outcomes corresponding to 2.5. All right, so that's going to be 2 out of 25. 3 has 1 outcome. 4 has 2. The next one also 2. Okay, so the next one has 1. The next one has 2. All right, you see what I've done. I have created a table. Excuse me. I have created a table. This is the second table. The first column gives the distinct possible values for X bar. The second column gives the probabilities. All right, now I can use this table to compute the expected value of X bar. The expected value of X bar is going to be this multiplied by this, and then take the sum. Right, so it's going to be 2 multiplied by 1 over 25. All the way up to 11 multiplied by 1 over 25. And if you compute this, this will be equal to 6. To find the variance of X bar, use this formula here. You will use this formula, right? This guy we already know is 6. 6 squared is 36. To find this guy, I will just say 2 squared times 1 over 25, all the way up to 11 squared times 1 over 25, minus 36, right? So this, if you compute this, this will be equal to 5.4. So the mean of the population mean of the sample mean is 6, and the population variance of the sample mean is 5.4. All right, guys, so that completes question 3. All right, any questions, anything that you'd like to ask? I mean, feel free to say, and if you did not understand things, please do feel free to use the chat box. Are you guys okay with this or what? Hello? Are you sure? Okay, good. Thank you. Thank you, guys. You guys being good today. Right. I mean, you're always good anyway. All right. Now, next one is question 4. Question 4 is just a repeat of question 3. Remember, in question 3, we did it with replacement, right? The difference in question 4 is that we're going to do the same thing without replacement, right? So the only difference is that we're going to do things without replacement. So we need to redo the tables one more time. All right. Okay. Now, without replacement, you can have the following outcomes. All right, these are the outcomes you can have. Now, you will see that I have included 2, 3, but not 3, 2. I have included 2, 6, but not 6, 2, and so on, right? The reason for that is because the order does not matter, right? And even if you include, like, for example, if you include 2, 3, and 3, 2, and 2, 6, and 6, 2, the answer that you will get at the end will be the same, right? All right, so the order in this case does not matter, because if you just try doing it with the different ordering, you will get the same answer, right? All right, so these are the outcomes, and the corresponding values for the mean are 2.5, 4, 5, 6.5, 4.5, 5.5, 7, 7, 8.5, and 9.5. All right, so that's the first table. The second table that we need to do is the following. We need to list here the possible values, the distinct values for X bar, which are 2.5, 4, 4.5, 5, 5.5, 6.5, 7, 8.5, and 9.5. Okay, these are the possible values for X bar, and the corresponding probabilities is all 1/10 except for 7, because 7, as you can see, you have 2 outcomes with X bar equal to 7. So for 7, you have 2/10. Otherwise, it is 1/10. All right. So this is the values for X bar, and these are the corresponding probabilities, right? Okay, guys. Now, the next thing I'm going to do is to compute the mean and the variance, right? To compute the mean and the variance, I'll do what I did earlier, right? So I'm going to compute first the expected value of X bar. So which we can just multiply this with this and sum. So you get 2.5 multiplied by this up to 9.5 multiplied by this. And if you do the math, you will get this to be 6, right? And the variance of X bar, to find the variance of X bar, you use this formula here. Right, you use this formula. This guy we already know is equal to 6. To find this guy, once again, you will use this table, right? So it's going to be 2.5 squared multiplied by 1/10 up to 9.5 squared multiplied by 1/10 minus 6 squared, which is 36, right? Now, if you work this out, this will be 4.05. All right, so this is the variance of the population variance of the sample mean, and this is the population mean of the sample mean. Now, you may recall what we got earlier. This is what we got. These are the numbers that we got under with replacement, and these are the numbers that we get under without replacement, right? So you see the difference, the 6 and the 6, they are the same, right? But the variance with replacement was 5.4. The variance without replacement is 4.05. So this one is better. Remember, the smaller the variance, the better the thing, right? But so what we're gonna write is the following: the means are the same, right? But the variance is smaller for without replacement. All right, you see the variance under without replacement is 4.05, which is smaller than the variance with replacement, which is 5.4, right? All right, so any questions on this, guys, before I go to next one, which is question 5? Don't be shy, guys. If you really don't understand, feel free to talk to me. If you really don't understand anything, just feel free to talk to me, guys. Are you sure? All of you guys okay? Hello, guys. Okay, guys, thank you. All right, the next question I'm going to do is question 5. Question 5 is this one. So you have a population that contains these 5 numbers, right? And the first question is to calculate the population mean. All right, so let's see how we can do this. This is question 5, part 1. Okay, so the population contains these numbers 3, 7, 9, 11, and 15, right? And we want to find the population mean. The population mean is simply, just the expectation, right? So it's basically you pick one of these numbers at random. So every one of them has equal probability, right? So it's going to be 3 times 1 over 5 plus 7 times 1 over 5 up to 15 times 1 over 5, right? If you compute this will be equal to 9. All right, so that completes part 1. Part 2 is to write down all possible outcomes when you choose 3 without replacement. This is without replacement, right? And then find the mean and the variance of the sampling distribution of X bar. All right, so let's see how we can do this. This is part 2 of question 5. So the first thing you need to do is this. You need to list the outcomes and the possible values for X bar. Because you're choosing 3 numbers, the possible outcomes are gonna be this, right? This is one possible. And also you're doing it without replacement, right? And finally 9, 11, 15. Okay, once again, the order does not matter. The order does not matter here because the reason for that is because even if you list the other possible orderings, the answer that you will get at the end will be the same, right? Okay, so here the order, like you can have 379 and 397 and 739 and all the other possible orderings, but eventually the answer that you're gonna get at the end will not change, right? Okay, all right. Now here I'm gonna compute the sample mean, which is 19 by 3, 21 by 3, 25 by 3, 23 by 3, 27 by 3, 29 by 3, 27 by 3, 31 by 3, 33 by 3, and finally 35 by 3. So these are the possible outcomes, sorry, the possible values for X bar and the possible outcomes. The next table I need to do is the following. I'm going to list here the distinct possible values for X bar and the corresponding probabilities. All right, the distinct possible values for X bar are as follows: 19 by 3, 21 by 3, 23 by 3, 25 by 3, 27 by 3, 29 by 3, 31 by 3, and 33 by 3, and 35 by 3. So these are the distinct possible values for X bar, and the corresponding probabilities are 1 over 10. There's one outcome corresponding to each possible value for X bar, except when it's 27 by 3, you have 2 outcomes. Right? You see there are 2 outcomes with 27 by 3, which is this one and this one. That is, this one and this one have both 27 by 3. So it's 2 divided by 10. All right, so this is the table that we need to use to compute the sample mean, sorry, the population mean and the population variance of X bar. So first of all, the population mean of X bar, you just multiply this column with this column and sum, right? Okay, so this is what you will get. You should do the multiplication, 19 by 3 multiplied by 1 over 10, all the way up to 35 by 3 multiplied by 1 over 10. All right, you will get this to be equal to 9. All right, and to find the population variance of X bar, right, use this formula. This one we already know is 9. And to compute this, I will use this table here, right? So it's gonna be 19 by 3 squared times this, all the way up to 35 by 3 squared times 1 over 10 minus 81. 81 is the square of 9, right? Okay, so this becomes equal to 2.667. All right, so this is the population mean of X bar, and this is the population variance of X bar, right? Are you guys with me okay so far? Any questions, just let me know. Feel free to talk to me. All right, the next part of question 5 is part 3. Now, use the list of possible samples to calculate the sample mean, to calculate the mean and the variance of the sampling distribution of the sample median. All right, this time we are interested in the sample median, not the sample mean, right? All right, so once again, we need to, so this is part 3 of question 5, okay? Why is it 81? It's 81, sir, because it's 9 squared. You should square 91. Sorry, you should square 9. It becomes 81, sir. Okay. Yeah. All right. So the first thing I'm going to do is to create the list of outcomes and the corresponding values for the median. So the outcomes are as before, 379. Right, this is one possible outcome, and 3711 is another possible outcome. 3 7, 15, 3, 9, 11, right, and all right, these are the outcomes that I had listed earlier. Now, for each of these, I'm going to list the median. Remember, the median is the middle value when you order the data from the smallest to the largest. So the median for this is 7. The median for this is 7. All right, so these are the medians, right? Okay, now the next table I'm going to do is the following. I'm going to list the distinct values for the median and the corresponding probabilities. There are only 3 possible values for the median, 7, 9, and 11. And 7 occurs 3 times, so it's 3 out of 10. 9 occurs 4 times, and 11 occurs 3 times, right? So this is the table I'm going to use in a minute to compute the population mean and the population variance, right? So let me show you how to do that. So let me put it here. Here we are. Okay, so to find the population mean of the sample median, all I have to do is multiply this column with this column and sum. So it's 7 times 3 over 10 up to 11 times 3 over 10. Okay, and this will give you 9. Okay, and to find the population variance of the sample median, okay, I will use the formula I mentioned earlier. Okay, this is the formula I mentioned here. Now this one we already know is 9, so 9 squared is 81. Now to find this, I'm going to use the table one more time. So it's going to be 7 squared by times 3 over 10 up to 11 squared times 3 over 10 minus square of 9 is 81. Right now, if you compute this, you get 2.4. So you see the comparison. You see the comparison between. If you go back to part 2, if you go back to part 2 of the same question, that's question 5. These are the values. These are the values that we got for the sample. These are the values that we got for the population mean and the population variance of the sample mean, right? And now we are getting these values for the population mean and the population variance of the sample median. The 9 and the 9 are the same, right? But the variance is 2.667 for the variance of the sample mean, and the variance is 2.4 for the variance of the sample median. So this one is better, right? Because 2.4 is smaller. So what you should write is as follows. The means are the same. Excuse me. Right. The means are the same. Right. The means are the same, right? But the variance is smaller for the sample median. All right. Okay, guys, so that completes question 5. Did you follow what I did in question 5, guys? Let me know if you did not. Or you should. Hello, guys, talk to me. Are you okay with question 5? All right, now let's go to question 6. We only have 5 minutes left, but let's see what I can do with question. So we're done with question 5. So the next one is question 6. The question 6 is, you have a random sample of size 10 from a uniform distribution. Excuse me, just hang on, right? I think I got a problem with the camera. Oh. I'm trying to free focus the camera. Okay, I think it's better now. How many questions will there be in a weekly quiz? Yeah, the weekly quiz is already online, sir. I mean, if you go to the course website, you see the weekly quiz. There's only one question every week. Can you see that? I mean, when you go to the course website, there is a weekly quiz, which you can see. You should be able to see that on the course website. I mean, the weekly quiz is on the course website, which I will type. I mean, if you go there, you should be able to see the quiz, which is due. By the way, the first quiz is due by 10 a.m. on Thursday this week, which is what's the date? Is Thursday? I can't remember. It's 18th. Yeah, Thursday, 18th of Feb. Right. All right. So you have a random sample from a uniform, and we want to find the mean and the variance. So let's start with the mean first, right? So this is gonna be this, right? Now if you take the expectation inside, this is gonna be now the expectation of a uniform variable, I'm sure all of you know, right? That if you don't know, let me write this down, that if X is a uniform variable on the interval A to B, then the expectation of X is equal to A plus B divided by 2, right? So using this, you should be able to figure out that the expectation of Xi is half. All right, so this is 1/10 times 10 times a half, which is equal to half. All right, so that completes the first part of question 6. The second part is to find the variance. The second part is to find the variance, guys. Variance of the sample mean. Okay, now if you take the variance inside, you will get 10 becomes 100 times the sum of the variance of Xi. Now, once again, you should know the following property. You should don't know, I mean, that if you have a uniform variable on the interval A to B, right, then the variance of that random variable is B minus A squared divided by 12. Okay, right? So using this formula, you will get 1 divided by 12, right? So this is 1 divided by 100 times 10 times 12, which is equal to 1 divided by this. So this completes question 6. Are you guys okay with this or what? I mean, please let me know if you're not okay. Question 7 I'm running out of time, but I will try to squeeze in if you don't mind. If you don't mind, by the way, are you okay with this question, guys? Yes. Any questions on this, guys? Are you okay? Yeah. All right. Thank you. All right. Let me move on to question 7, which is the final question on this tutorial sheet. This is question 7. The question 7 is asking you to find the joint probability. You are given six values from a Poisson distribution with parameter lambda, right? So you can write this as because of independence, you can write this like this, right? Okay, and this you can write as I from 1 to 6 of the probability that xi equals to little xi, right? Okay, now we know that this is a Poisson variable, so this you can write as e of minus lambda power xi divided by xi factorial, right? I mean, this is, I'm sure all of you know this formula. This is the probability mass function of the Poisson distribution. All right, so this is what you get. Now, if you sub in the values that you have, you are given the values for the x's, right? Now, if you sub them into this formula, this is what you will get. The sum of xi will become 59, right? And in the bottom, you will have 9 factorial, 13 factorial, 6 factorial, 8 factorial, 10 factorial, and 13 factorial. So let me call this star, right? Let me call this star. Now you are told that lambda takes 2 different values, 10 or 12. The question is which one is more likely? So if lambda is equal to 10, right, then if you have a calculator, you can work out this for lambda equal to 10, and you will get this. And if lambda is equal to 12, you will get star to be equal to 1.704 times 10 to the power minus 7, right? So the question is which one is more likely? So in other words, which one has a higher probability? And clearly this probability is larger than this probability. So therefore the answer to question 7 is lambda equal to 10 is more likely to occur. Okay, is that clear to all of you guys? Because the value that is more likely to occur is the one that has the higher probability. Yeah, and in this case, lambda equal to 10 has higher probability, and therefore it is more likely to occur than lambda equal to 12. All right, guys, so this completes the tutorial sheet 2, right? And by the way, I will post all the solutions to the 7 questions on the course website later this week on Thursday. So on Thursday, you should be able to see, the full solutions to all 7 questions, right? I mean, which I have already given to you, right? Okay. All right, guys, have a good day. Have a great day, and I will talk to you soon, right? Hello. Hello. Hello guys, are you okay? Good morning or good afternoon or good evening, wherever you are.
Greetings, greetings.
Okay, thank you, sir. All right, guys. Good afternoon or good evening, wherever you are, or good morning. So today I'm gonna go through tutorial sheet 2. There are 7 questions in this tutorial. Okay, and I will try to go through as many as possible. All right, so let's start with question 1. So this is question 1. I'm not sure if you can read it, but if you can't read this, but you can see it, the online version on the course website. So if you go to the course website under week 2, you will be able to see a PDF file of this, right? Okay, so the question is as follows. You have people are looking for a representative sample of waters in the UK. And the question is whether each of these following, there are five parts, whether each of them is a representative sample or not. Right. So let's start with part one. This is question one, part one. Part one is asking you whether you should poll all people of voting age attending a football game. Is it likely to be representative or not? It's not likely to be representative, right? It's not going to be a representative sample because not a representative sample because not every voter likes football. Like, for example, I don't like football, so I mean, not everybody likes football, right? I'm sure there are many people who don't like football, and right, so they may not attend a football game, right? Okay. Okay, guys. So that's part one. Part two is saying whether poll all people of voting age living in an expensive restaurant on a particular evening. That's also not a representative sample because not everybody can go to an expensive restaurant. Not a representative. Because not every voter can afford an expensive restaurant. Okay. All right, guys. So any question? If you have any question, just feel free to use the chat room or talk to me directly using your microphone. All right. So don't be shy. I mean, I'm here to help you 24/7. All right. Okay. Part three is to obtain a copy of voter registration and randomly choose 500 names and ask them about their voting intention. So in this case, it is yes, it is a representative. Yes, it is a representative sample because you are actually using a voter registration list. So it's likely to be a representative of voters in the country, right? Okay, guys. So part three is a representative sample. Part four, use the results of a telephone poll in which a television station asked its viewers to call and state their voting preference. Now, this is not a representative sample because number one, not everybody may have a telephone. I know it's unlikely here. And number two, not everybody watches television. Like I don't like to watch television, right? Okay, so this is not a representative. Not a representative sample because not every voter may have a telephone or likes to watch television, right? Okay, and part five is this: choose 200 names randomly from a telephone directory and call them. That's, once again, it's not a representative sample because not everybody is, I mean, some people don't want to be listed in the directory, as you know. for privacy reasons, some people are not listed in the telephone directory. Okay, so this is not a representative. Not a representative sample, because not every voter may be in the telephone directory. Okay, guys, are you okay with this? All right, you have it. Okay, that's question 1 done. Before I go to question 2, can you please tell me if you're okay with this or not? I mean, feel free to talk to me, guys. I'm really genuinely want to help you guys, and that's why I've given you all my contact details, including my home phone number. So are you guys okay with this or not? Hello. Okay, thank you, guys. Thank you. Thank you very much. All right, next question is question 2. Question 2 is similar to question 1. So again, once again, the question is whether the sample is representative or not, right? Okay, so this is question 2, part 1. Part 1 is to determine the average, to determine what the average person spends on a vacation. A market researcher interviews passengers aboard a luxury cruise liner. And this is clearly not a representative sample. Because only the rich can afford a luxury cruise liner, because only the rich can afford a luxury cruise liner. Okay, all right, guys, so that's part 1. Part 2, to determine the average income of graduates 10 years after graduation, a university sends questionnaires in 2015 to a class of 2005 and bases its estimates on the questionnaires returned. Right, here is not, once again, is not a representative sample, because I will explain why. Because they are not likely to report their true income, because only because graduates are not likely to report their true income. Right. For example, if somebody earns, say, for example, somebody earns, say, £1 million per year, then they may think it's too posh to report that, right? And on the other hand, if somebody earns, say, £10,000 per year, and they may feel like embarrassed to report that they are only earning like 10,000 quid a year, right? Okay, so it's clearly not a representative sample. Now, part 3 is this one: to determine a public sentiment about certain import restriction from a country. An interviewer asks, do you feel that this unfair practice should be stopped? Because of the wording of the question, right? I mean, if you read the question, it says, do you feel that this unfair practice should be stopped? The people who think it is fair will say it is unfair. So that's because of the wording of the question is not correct, right? So it's not likely to yield a representative sample of answers, right? Okay, so once again, this is not a representative sample. Right, because of the wording. Because of the wording of the question. Right, you see the question raised like this: do you feel that this unfair practice should be stopped? So even if people think it is fair, are likely to say it is unfair. So it's not likely to yield a representative sample of answers. Right. Okay, so this completes question 2. Are you guys okay with this or not? Hello guys, talk to me. Are you okay with question 2, or do you have anything you want to ask? Okay, thank you guys. All right, so let me move on to the next question, which is question 3. Question 3 is this one, right? So you have a population that is made up of these numbers 2, 3, 6, 8, and 11. And the first part is to compute the population mean. So this is question 3, part 1. So the population is made up of these numbers 2, 3, 6, 8, and 11. And you're picking one number at random. All right, so the number can be either 2, 3, 6, 8, or 11. And the corresponding probabilities are 1 over 5, 1 over 5, 1 over 5, 1 over 5, 1 over 5. All right. So to compute the population mean, what you have to do is just simply multiply this with this and sum, right? So this is going to be 2 times 1 over 5 all the way up to 11 times 1 over 5, which if you do the math, for this, you will get it to be equal to 6, right? So that's part 1. Now to do part 2 is to compute the population variance. So to compute the population variance, which is the variance denoted by this, okay? I'm going to use the following formula. Okay, now this guy we already know is equal to 6, yeah? And so we just need to work this out, right? So to work this out, I'm going to use this table one more time. So it's going to be 2 squared times 1 over 5 all the way up to 11 squared times 1 over 5 minus the square of this, which is 36. And if you work this out, this will be 10.8. So the variance is 10.8, okay? All right, and the third part is to consider all possible samples and find the sampling distribution of X bar. All right, now to do this, the first thing you need to do is the following. Let me take this away. So this is question 3, part 3. All right. The first thing you need to do is to have a table with the outcomes for the 2 numbers that you're selecting with replacement. Remember, we are doing this with replacement, right? With replacement, that's crucial. and then the corresponding values for X bar. Okay. So the outcomes are going to be 2, 2, 2, 3, 2, 6, 2, 8, 2, 11. So these, because you are doing it with replacement, you can have 2, 2, 2, 3, 2, 6, 2, 8, 2, 11, and then you can have 3, 2, you can have 3, 3, you can have 3, 6, 3, 8, 3, 11, right? And then you can have 6, 2, 6, 3, 6, 6, 6, 8, and 6, 11. And then you can have 8, 8, 2, 8, 3, 8, 6, 8, 8, and 8, 11. And finally, you can have 11, 2, 11, 3, 11, 6, 11, 8, and 11, 11. So these you have in total 25 possible outcomes, right? Now what I'm going to list in this column is the values for X bar. So 2, 2, the average is 2. For 2, 3, the average is 2.5. For 2, 6, the average is 4, and so on, all right? Correct me if I'm wrong. I mean, I might get the averages wrong sometimes, you know. All right, so you see what I've done. I create this table with the first column giving the outcomes and the second column giving the values for X bar. Now the next thing I need to do, is another table. In this table, I'm going to have 2 columns. The first column gives the values for X bar. The second column gives the values, the probabilities. Now, you should look at this table here, the table that we just finished, right? The distinct possible values for X bar are as follows: 2, 2.5, 3, 4, 4.5, 5, 5.5, 6, 6.5, 7, 8, 8.5, 9.5, and 11. These are the different possible values for X bar, right, in the table that I just did. Now for 2, how many? There's only 1 2, right, corresponding to this outcome, right? So the probability is 1/25. For 2.5, there are 2 outcomes. There's this one, right? And there's this one. There are 2 outcomes with 2.5. All right, so this is gonna be 2 divided by 25. The next one, for the next one is gonna be 1/25. For the next one is 2/25, 2/25, 2/25, 2/25, and then it's 1/25, then it's 2/25. For 7 occurs 4 times. I mean, if you look at this table here, you will see there are 7 outcomes. There are, 4 outcomes with X bar equal to 7, right? Okay, and then is 1/25, 2/25, 2/25, and finally 1/25. So you see what I've done. I have created a second table that gives the values for X bar, I mean the different values for X bar and the corresponding probabilities, right? All right, now I'm going to use this table to compute the expectation and the variance of X bar. So to find the expectation of this, all you have to do is to multiply this with this and then take the sum. So it's going to be 2 times this up to all the way up to 11 times this. And if you do the math, this will be equal to 6, right? Now to find the variance of x bar, you use this formula. I'm sure you know this formula. Yeah, this is the formula for the variance of a random variable. This guy we already know is 6. So we just need to figure this out. To figure this out, you will just do the same thing as I did. It's going to be 2 squared times 1/25 all the way up to 11 squared times 1/25. Take away 6 squared, which is 36. Now, if you do the math, this will be 5.4. All right, guys, so this completes question 3. Are you guys okay or no? Are you okay with what I've done with question 3? Especially part 3. Part 3 is the important part, okay? Where you have to do 2 tables. The first table, remember, the first table lists the outcomes and the possible values for x bar. The second table lists the different possible values for x bar and the probabilities. And you can use this table to find this and this, right? Okay, all right, so that's question 3, we are done. The next question is question 4. All right, question 4 is just a continuation of question 3. The difference is here, you see we did it with replacement, and here we're gonna do without replacement. So that's the difference in question 3. Sorry, question 4, I mean question 4. So it's question 4. The first thing we need to do is outcomes. Okay, and the second thing is x bar. All right, so I'm going to list the possible outcomes. Remember, now I'm doing it without replacement. So 2, 2 is not possible. 2, 3 is possible, right? 2, 6 is possible. 2, 8, 2, 11, 3, 6, 3, 8, 3, 11, 6, 8, 6, 11, and 8, 11. So these are the possible outcomes. You may think why I haven't included 3, 2, and 2, 3. That's because the order does not matter here, because even, all right, suppose you include 2, 3, and 3, 2, and 2, 6, and 6, 2, and so on. The answer that you will get at the end will be the same. I mean, you can try it yourself. You can try that yourself, all right? The order here does not matter because it will give the same answer, right? So for 2, 3, the average is 2.5. For 2, 6, the average is 4, 5, 6.5, 4.5, 5.5, 7, 7, 8.5, 9.5. Right, so that's the first table. The second table that I need to do is, right, this table. Here I'm going to list the possible values for x bar, the different values for x bar, which are 2.5, 4, 4.5, 5, 5.5, 6.5, 7, 8.5, and 9.5. All right, these are the different values for x bar, and the corresponding probabilities are 1/10, all right, 7, you see 7 has 2 outcomes. See, this outcome gives 7. Both these outcomes give x bar equal to 7. So the probability is 2/10 for 7, but for others it's 1/10. All right, so this is the table I'm going to use to compute. All right, this is the table that I'm going to use to compute the probability, right? Okay. Um, okay, so we're done with. Excuse me, I'm lost. Just give me a second, guys. All right. Okay, so now I'm going to compute the probable. I'm going to compute. I'm going to compute the population mean of X bar and the population variance of X bar. So this is going to be, to compute this, I'm going to multiply this column with this column and take the sum. So it's going to be okay. Now if you take the sum of this will be 6. Now to compute the variance of X bar, I'm going to use the formula that I mentioned earlier, which is this one. Okay. So I just need to work this out because this one we already know is 6, right? So it's going to be so 6 squared is 36. Now if you work this out, this will be 4.05. Okay. Now you should go back to what I did earlier. This is what I had earlier. This is when I had, these are the numbers I got when it's width replacement. Right? And these are the numbers I'm getting now when it's without replacement, right? Well, I got one question, why the order does not matter again. Yeah, the order does not matter because you have to actually go through the working, right? You should go back to this table. You should go back to this table and include, sorry. Okay, before I answer the question, let me finish this. All right, let me finish this, guys, first. So these are the estimates I got with replacement, and these are the estimates I got without replacement. So you see the means are the same. The means are the same. The means are the same, but the variance is smaller for without replacement. Right, okay, all right, so this completes question 4, but let me answer one guy who asked me a question. Why, the question was this, why the order does not matter? So that's a good question. The reason for that is because you should go back to question 4. This is question 4, right? This is question 4, right? Now, in this question, if you include 2, 3 and 3, 2, 2, 6 and 6, 2, 2, 8 and 8, 2 and so on, and compute the X bar as I've done here, and then come to this table here where you list all possible values for X bar and the corresponding probabilities. This table here, the table here will not change, right? This table will be the same. Will be the same whether right? This table here will be the same, whether you include the ordering, the different orderings, or not include the different orderings. Like, okay, like if you include all the possible orderings, like 3, 2, 2, 3, 2, 6, 6, 2, 2, 8, 8, 2, and so on, and do this table one more time, you will get this exactly the same. You will get exactly the same as what I have got here, right? Okay, so that's what I meant when I said the ordering does not matter. Okay, all right, guys. So that's question 4. We are done. Any questions on question 4 before I go to the next one, guys? Hello, guys. We are done with question 4. Anything you like to ask on question 4? What I did? All right, thank you, guys. All right, so let's move on to the next question, which is question 5. Question 5 is this one. So you have a population made up of 5 numbers. The first part is to compute the population mean, right? Right. So this is question 5, part 1. The population is made up of these numbers 3, 7, 9, 11, and 15. Right. So the possible outcomes and the probabilities are as follows. It will be, the outcome can be either 3, 7, 9, 11, or 15, and the probability will be 1/5. Yeah. All right, so to find the population mean, all you have to do is just multiply this with this and sum, right? So it's gonna be 3 times 1/5 all the way up to 15 times 1/5. And if you do the math, this will be 9. All right, so that's part 1. Part 2 is to write down all possible samples and without replacement and calculate the mean and the variance of X bar. Okay, so once again, I'm gonna do the table. Now here, we're gonna pick 3 numbers, not just 2, but 3 numbers without replacement, right? So the outcomes, these are the outcomes and these are the possible values for X bar. The outcomes are gonna be this. Once again, the order does not matter. I mean, the same explanation I gave you in the last example apply here, right? You can include the other orderings, but nothing will change. All right, so these are the possible orderings and the corresponding values for X bar. This is 19/3, 21/3, 25/3, 23/3, 27/3, 29/3, 27/3, 31/3, 33/3, and finally 35/3. So once again, I should mention here the ordering. The ordering does not matter here because the probability table that I'm going to do now in a second is not going to change, whether you include the orderings or not, right? So this is the table with the outcomes and the values for X bar. The next table I'm going to do is the probability table, right? So which is This is where you list the possible values for X bar and the corresponding probabilities. Okay. The different possible values for X bar are as follows: 19 by 3, 21 by 3, 23 by 3, 25 by 3, 27 by 3, 29 by 3, 31 by 3, 33 by 3, and 35 by 3. All right, and the corresponding probabilities are all 1/10 except for one case, except for 27 by 3 occurs 2 times, right? As you can see, this one gives 27 by 3, and this one also gives 27 by 3. So you have 2 out of 10 for that, and otherwise it's all 1/10. Okay, so this is the probability table. Now, using the probability table, I can work out the mean and the variance, right? Just give me a sec, guys. The mean and the variance will turn out to be, excuse me, question four, yeah. All right, so the mean is going, so to find the mean, first of all, to find the mean, all you have to do is just multiply this column with this column and then sum. So this is going to be 19 by 3 multiplied by 1/10, all the way up to 35 by 3 multiplied by 1/10. And if you do the math, this will be 9, right? And to find the variance of the sample mean, you use the formula that I gave you earlier, which is this one, right? Okay, now we know what this is already. It's 9. 9 squared is 81. Now to find this, minus 81, right? Now if you do the math for this, you will get 2.667. All right, so that's the variance of the sample mean, and this is the mean of the sample mean, right? All right, so that completes part. Which part is that? Part 3, I think. Right. Oh, is it part 3 or part 2? Oh, sorry, it's part 2. Part 2. So it completes part 2 of question 5. The next part is to do the same thing, but compute the sample median instead of the sample mean, right? So what I'm going to do is, this is part 3, question 5, part 3, right? What I'm going to do is, first of all, I'm going to list the possible outcomes one more time. If anything not clear, guys, please feel free to talk to me or write on the chat room, right? The possible outcomes are 3, same as before, right? All right, these are the possible outcomes for which I already mentioned to you earlier. Now the median, remember the median is the middle number when you arrange the data from the smallest to the largest. So the middle number here is 7. The middle number here is 7, 7, 9, 9, 11, 9, 9, 11, 11. All right. So I've done this table. The next thing I need to do is to do the probability table. Right? The probability table is going to look like this. The different possible values for the median and the corresponding probabilities. All right. So there are only 3 different values for the median, 7, 9, or 11. Right, and the corresponding probabilities are 3. There are 3 different values for 7, and there are 4 different values for 9, and 3 for 11. Right. You see, there are 4 9s, there are 3 7s, and there are 3 11s. Right. So this is what you get. Right now, we can use this table to compute the expectation and the variance of the sample mean. So to compute the expectation, we just say this, right? And this will turn out to be equal to 9. To compute the variance, we use the formula that I mentioned a couple of times already. All right. So it's going to be equal to 7 squared times 3 over 10, all the way up to 11 squared times 3 over 10, minus the square of 9, which is 81. So this is equal to 2.4, right? So this is what we are getting. Now I'm gonna, all right, now let me put this in a box. These are the values I'm getting for the sample median. And if you may recall, just a few minutes ago, just a few seconds ago actually, these are the values that I got. These are the values that I got for the sample mean, 9 and 2.667. Now I'm getting 9 and 2.4. 2.4 is smaller than 2.667. So the conclusion is as follows. So this is part 4 of question 5. The means are the same. The means are the same, right? But the variance is smaller for the sample median. For the sample median. All right, guys, are you guys okay with this? This completes question 5, I think. Yeah, question 5. Any questions on this, guys? Hello, guys. Talk to me, guys, please. Are you sure? I mean, don't be shy, guys. Don't be shy. I mean, you can call me 24/7, by any means, right? Okay. Now the next question is question 6. Question 6 says, I'm not sure whether you can see it clearly or not, but it says that you have a random sample of size 10 from a uniform distribution, right? And calculate the mean and the variance of X bar. No, the biased and unbiased do not come here, sir. The biased and unbiased version comes when you compute the sample variance or the sample. Now here we are not computing the sample variance. Here we are computing the the population variance, right? I know I gave you 2 different formulas for computing the sample variance. One is biased, the other one is unbiased, right? But those do not come into the questions that I have done today, right? Because the questions I have done today are about the population variance, not about the sample variance. You shouldn't confuse the 2, guys. The population variance, you use VAR, right? to compute the sample variance, you use one of the two formulas I gave you in the class, right? So you shouldn't confuse the two, guys. All right, because one of you, I mean, the biased and the unbiased version are for the sample variance. They're nothing to do with the population variance. All right, I hope, I mean, just try to make, I know it's easy to confuse. It's easy to confuse, but I mean, but if you're still not clear, please talk to me in person or email me or call me or whatever, right? All right, this is question 6 I'm doing now. The first part is to find the expectation of X bar, which is this. Now, you know that if X is a uniform variable, then the formula for the expectation is A plus B by 2, right? So I'm going to use this here. So it will be 1 over 10 okay, like this. So this will be 1 over 10 times half, which is equal to half. So that's the answer to the first part. Now the answer to the second part of question 6 is as follows. Right. All right, taking the variance inside, you need to, when you pull out a constant, you need to square it. So this becomes 100 times the sum of the variance of xi. Now, I don't know whether you remember from probability 1 that you did last semester that if you have a uniform variable from A to B, right, then the formula for the variance is equal to B minus A squared divided by 12. Do you guys remember this? No. All right, Vincent, U01 means uniform from 0 to 1. So it's uniform, or 0, 1 means it's a uniform variable from 0 to 1. I mean, uniform distribution, right? So using this, it becomes 1 to 10 of this, right? Is that clear, Vincent? I mean, U in bracket 0, 1 means simply a uniform random variable with parameters 0 and 1. All right, so this becomes 1 over 12. So this becomes 1 divided by 120. All right. So this completes question 6, right? I don't have the time. I seem to have run out of time to do question 7. By the way, before I leave, before I complete, you have any questions on this question 6? Are you guys okay with this? Or not? Any question? Hello guys, talk to me. Are you guys okay with question 6 or not? Okay, thank you guys. Thank you. All right, so there's only one more question I haven't done, which is question 7. But I will post the full solutions to all 7 questions later this week. That is on Thursday, day after tomorrow. I will post the full solutions to all 7 questions. There will be 3 different versions of solution. One is a typed version, the other one is a handwritten version, and the third one will be a video solutions to all 7 questions. All right, so you can watch all 3 of them now, or any one of them you like. Okay, guys. So Is there anything else you'd like to talk to me about apart from the tutorial? Like any questions you have about the, by the way, the quiz one is due on Thursday this week by 10 a.m. I mean, if you haven't looked at the quiz, let me show you where it is. The quiz is you should go to the course website. You should go to the course website, which is, let me show you where it is. Excuse me. This is not the course website. This is the course website is this one, right? You should go here and look at the quiz for this week, which is over here, right? This is the quiz for the quiz number 1, right? And you should submit the answer to this quiz by 10 a.m. 10 a.m. on 18th of Feb, right? So please. All right, there's one more question I've got here. What is the difference between sample variance and population variance? The sample variance, like normally a population cannot be accessed. Like for example, if you want to know the average age of everyone in the UK, that's impossible to compute because there are so many millions of people in the UK. So what people do is they just draw a sample, like say a sample of say 1,000 people, and then find out what their age is, right? And then compute the mean and the variance and so on. So the sample mean and the sample variance refer to a sample, which is a subset of the population, right? Whereas population mean and population variance refer to the population. Right, the population mean and the population mean refer to the population, and the population usually cannot be accessed. Just like if you want to compute the age of all people in the UK, you can't access the population. You can only access a sample, like let's say 1,000 people or so, right? All right, that's why the sample mean and the sample variance comes in. All right, I've got one more question from Mikhail about quiz 1. Yeah, you don't need to submit the full solutions to quiz 1. You only need to select one of the 4 possible answers, A, B, C, or D, right? And if you select the right answer, you will get 1 mark. And if you select the wrong answer, then you will get 0 mark. And on Thursday, I will send you an email with what the correct answer is and how the correct answer was obtained. I mean, it's not trivial. I mean, none of these quizzes are trivial. I mean, it will take a while for you to find out which one is the right answer, right? So I will explain how I got the correct answer on Thursday when I send you an email. I've got one more question. Is that always the case for with and without replacement? That may not be true. I mean, sometimes with replacement may be better than without replacement. Sometimes the without replacement may be better than with replacement. So it depends on the situation. It depends on the situation. So they may not be the same all the time. They may not be the same all the time, right? Yeah. All right, guys. Any other questions? Feel free to use the chat room. All right, guys. So have a great afternoon or evening or morning, wherever you are. So I will talk to you guys soon. And any questions? For any questions you have, you know who to contact. I mean, you can contact me by phone, by Zoom, by Skype, or by email, right? Okay, have a great day, guys, right?